the next speaker, and the last actually for this session before the panel discussion, is Alan Burton from the University of Michigan, speaking about, so he's sort of bridging between some of the aquatic ecosystem effects and human health effects in his talk. So welcome, Alan Burton.
Thank you. Well, thank you. It's a real pleasure to be here and see so much interest. When I wrote my first opinion piece back in 2015, I was called by the head of 5Gyre and I was persecuted on social media. But since that time, there were about 150 papers published that year. It's been going up about 60% a year, and this last year there were almost 1,000 microplastic papers published. And I think this subject, this science, is just going through the same growing pains as any new science does. And so initially you have some papers that, are not using maybe the optimal methods, but, the improvement in the science in the last year or two is really amazing. So let me talk about, I want to step back for a second because I'm a big picture guy. I deal with ecosystems. So I'm dealing with thousands of species, not one, and wondering, what it is that's affecting those guys. And I think we can use a lot of these issues and processes and in application to human health issues. So let's think about what all the aquatic ecosystem is exposed to in our human-dominated watersheds. And here's a long list of the real things that we know cause a problem and really impair biological integrity in these systems. And it's not until we get down here with a really popular topic, pharmaceuticals and personal care products, where again we see a lot of effects in the lab, but population effects, they're really hard to find. Salts, everybody thinks that's really bad, but when you actually go out there and look at the ecosystem during the winter when salts are being applied, can't really see much. And then our topic today. So let's delve into that in a little more detail. And this is the latest summary that the US EPA did of all the state data where the states go out and identify what it is that's impairing their waters of the state. Rivers, wetlands, lakes, coastal waters, all of that. And they summarize it all. And here it is. And you see pathogens, nutrients, metals, organic enrichments. Those are by far and away, causing the worst impairment. And, over 40% of the waters are classified as poor. We've got mercury in all of these waters. They aren't identifying the microplastics that we're talking about today. They're not really looking at the pharmaceuticals and all. But these are the things that they really have a good hunch are causing the problem. And then down here at the bottom, I say developing countries. Developing countries have this very same issues, they're just bigger because of the lack of treatment that's going on. This is a great summary study, again, by the EPA, where they went out and randomly picked spots across the country. Well over 1,000 sites that they went to and assessed those. So these would be like reference sites and then occasionally impacted sites that were selected. And then they broke it out by ecoregion. And look, I find this interesting, and you can't see it, but I'll tell you. First off, the USGS did a great study not too long ago that found pesticides were in 90% of our streams at toxic levels across the country. Pesticides, remember, are designed to kill, not like microplastics. They're really designed to kill. And so this is a huge issue. And if you look at all of the rankings here, clear across the country, they pretty much come out like this. Nutrients, far and away the biggest problem. 46% of the impairments are due to nutrients. riparian vegetation, and then riparian disturbance. So that's affecting the things that fall into the streams and the runoff that comes into the streams. If there's more disturbance, more stuff's going to run off into the stream. And then finally, some of it due to riparian disturbance is elevated sediments. You're basically smothering the bottom of the streams with silt and clay, which is really causing impairments. And then they looked at mercury and PFAS. PFAS is the new hot thing, and found that 26% of the fish had mercury at elevated levels that were of concern, and 11% had PFAS. A lot of bad stuff going on out there that we know about, and this is really well documented. And then a paper that just came out last week in Science that looks at the relative risk of the chemicals that are found in these waterways and ranks them by occurrence and by their toxicity. And this, I find this really interesting because we've got copper at number 1, and copper is just everywhere, isn't it? But it's also one of the metals that's considered the most toxic. That's why it's been used in anti-fouling paints. It kills organisms. And then zinc, triclosan, chlorpyrifos, a really hot pesticide. But you see, this ranking to me is really important because it tells us what's the most important risk out there. We've seen some of this stuff today already. I saw something just this past week saying that by 2050, that petrochemical companies, half of their oil would be used for plastic production. Right now, it's 14%. And it's doubling every couple of decades. So, folks, this is just going to get a lot worse. So what we're talking about today is these current levels that are much lower than they're going to be in even 10 years. And we're talking about mainly the 300 to 500 micron size, which is where we have most of the data. And we know that the smaller stuff is an issue. A great study out of Scripps this past year in Science also showing an exponential increase in microplastics in the more recent sediments since 1940s. And so every year we're getting, every few years it's doubling in the sediments. And as somebody said, Kay Ho, everything ends up in the sediments. That's the sponge for all the bad stuff. And so the concentrations will continue to go up. So you've seen some of these pictures already. I won't dwell on them, but I will go back and point out this little guy over here. And remember this picture right now with this fluorescence, and we'll talk about that in a minute. The Lake Erie has been found to have up to 1 million microplastic particles in that trawl of 500 to 300 size range, which is as bad as some of the worst areas in the world. We went out there and sampled 150 fish, 6 different species that really were at risk. They were eating things on the surface. And out of those 150 fish, we found that 30% of them had a microfiber or up to 6 microfibers in just a handful. So no microbeads and no microfragments. And this was in the worst site we could find in Lake Erie. So another really great paper that came out recently, I believe this was Science or Nature, was sounding the alarm over oceanic slicks, where you get currents going and the fish larvae concentrate. Well, the microplastics do also. So they're in close proximity to microplastics as shown in this cartoon here with the slick running through here. And so they took a huge numbers of samples for water and identified the microplastics, and then they looked at the fish larvae and they said, this is a big deal. Well, I started looking at the data again, and it turns out, that 99% of these fish larvae are going to die anyway, natural mortality. And they found only 8.6% had microplastics, and they weren't the fragments, they were 1 microfiber. There was 1 fish that had 2. So I really question whether, is this an important risk? It's a phenomenon that's happening. Maybe in a few years, that exposure will be higher. The worst waters in the world that we've found are in Southeast Asia. And if you look at the PNEX, the threshold concentrations that actually cause adverse effects versus the concentrations in the water, Asia is the only place we can find where we might actually have concentrations that should be lethal. And that's only about 0.4% of the waters there. Come on. There we go. Oop. Did we skip? No. Okay, one of the issues that's certainly of relevance to this audience is the absorption of pollutants onto plastics. And we know, of course, that happens because plastics do that. And here's some old data that shows you high concentrations of PCBs from 2011 that were taken around the world. So is this a threat? Is it actually a threat? Well, remember, it's all about exposure. So let's come back to that. If you look at sorption work, and some of the stuff that I'm going to be presenting on this slide and the next slide actually came from Bart Coleman's lab in a critical review he did, the additives that are there, the things like nonylphenol and BPA, they're leaching out, but the concentrations that are actually leaching out are below the levels we tend to find out there. So it's a negligible pathway. There are concerns, of course, about the microplastics being taken up through the tissue, deposited in the liver, and things like that. And those studies that use fluorescent particles, like you saw on that little Daphnia in the preceding slide, going in and checking those again, they're finding that the fluorescent dye is actually leaching off of the particles, and it's the dye that's going through the membranes. So if we assume the barrier, the micron barrier for membranes is going to be around 0.3 microns, that's going to take out a lot of those particles, but we don't know about the smaller ones. We know, as you'll see from the next slide, that prey ingestion is really going to dominate, and interesting studies that are finding that the microplastics actually clean out organisms because they sorb these halogenated organic compounds that may be in the organism as they go through the gastrointestinal tract. So here's some more of Bart's work, and you can see this top figure here, which is the mass of these different compartments in the ocean. And note that both of these are on the log scale. So water, of course, and then dissolved organic carbon, colloids, detritus, phytoplankton, bacteria, zooplankton, black carbon, last plastics. And then if you look at the amount of organic halogenated compounds that are sorbed to these plastics, you get a very similar relationship, of course. But they love black carbon, so a little bit higher down there. But again, it's extremely small, and this helps show that it's just impossible. If a plastic is in water where there's contaminants, it's going to preferentially sorb to a lot of this organic carbon that's the greater mass. And so that is going to be the route for uptake into organisms, or it will sorb to organisms. But the microplastics are just going to be a minor vector for that uptake compared to prey. The partitioning process is fairly slow. And if you think about most of the plastic that's out there has been there a couple of years, basically your plastic particles are at equilibrium with these compounds. And the desorption rate is relatively slow from these compounds. So when they go through an organism, they tend to just go on through. So mussels that we saw earlier today is a great example. These particles are going through the organism and they're being defecated out the other end. And they don't have time to desorb within the organism. So I believe it was Greg that said earlier, was using silica and dust kind of as an analog because we know a lot about that with humans. I think we can do the same thing with total suspended solids. All of the states have criteria for TSS. And TSS, suspended solids, incorporates the whole range that we're talking about here, from colloids all the way up to large particles. And there's been a ton of research done on what causes a toxic effect from suspended solids. And the most sensitive species out there, like trout and salmon, are going to be down at the 100 milligram per liter range. So this is orders of magnitude higher than we have with the microplastics. Maybe not in Asia, maybe not in a few years, but at this point, I think it's a good analog because the damage is primarily due to physical issues. So this is a great unknown because fibers are the microplastic that's the most misidentified. A lot of the fibers are natural, but it's predicted that 90% of the microplastics out there are fibers. So at some of the sites, we really have documented that well. A lot of sites have shown fragments to be the major particles, but you start to wonder, is that due to methods or not? And a recent study showed 4 billion a day coming down a stream in Indiana into Lake Michigan. And it's not a very big stream. And they also found that once it got out to Lake Michigan, the beach that was there actually had higher concentrations off the beach. And they were suggesting that beach is just acting like a little sponge, and the wave action is regenerating those fibers into the water. So these really small fibers, I think we're really missing in the big story here. And then the study that came out this year on the tire particles going into San Francisco Bay was dramatic. And I was actually so glad to see it because I've been whining about this for a long time. If you think about the billions of tons of tire particles that are out there, that are on the sides of our roads that undoubtedly are ending up in sediments, they're going to be extremely small, and they're made up of a complex of organic compounds and very often zinc. And zinc is one of the more toxic metals. So we know tire particles are toxic. And if we've got 7 trillion a year coming into San Francisco Bay from non-point source runoff, I think that's something we should be worried about. And this is an area that's just wide open. We don't know much about it. So where are they a problem, besides some places in Southeast Asia? Basically, it's going to be any depositional sediment that's near an outfall, whether it be a stormwater outfall or a wastewater treatment outfall. The particles will end up in the sediments, and they will concentrate there. And if we have a continual source, they'll start to build up. And they may even build up to a level that causes toxicity. But again, think about the organisms that are actually ingesting sediment as part of their feeding mechanism. They're also ingesting millions to billions of organic or inorganic particles right along with those microplastics. So again, the microplastic is just a minor component, and contaminants will also be sorbed on those other sediment particles that are there. The urbanized streams, I think, are the ones of biggest concern. But again, the urban stream syndrome has been around for decades. We know that any waterway going through an urban area that has as little as 5% urban development will be impaired because of urban runoff. So there's a lot of bad stuff going on in our urban areas when it comes to biological integrity. I think we may actually be missing the boat on microplastics, and I mean that literally. There's only been a couple of good studies out there that have looked at this fraction that's 50 micron and smaller. And a couple of those came from South Korea, and they were done in near coastal areas, near harbors. And they found orders of magnitude higher, very small particles that were actually anti-fouling paint chips. So you think about every marine boat is going to have anti-fouling paint on it. And one of the ways it works is to slough off so that things can't grow on it. And the new paints are impregnated with thousands of fibers. So you can have 1 billion fibers on a boat hull. So we're getting the anti-fouling paint chips, which are toxic. It's usually zinc or copper, along with fibers. And they're at extremely high concentrations, with half of the particles being smaller than 50 microns. Now, no one's looking at that. Why? Because it's a pain. It's really, really hard to do. But we're going to have to bite the bullet. And with this size range, obviously, is going down to the nano area. It's this, to me, it's that 100 micron area down into the nano range is what we really need to be looking at. Risk is exposure and effects. Exposure. And that's where we've missed the boat on. I'd say I saw 86% of the studies that have been done in the lab have been at concentrations that are unrealistic. We've got to start doing realistic studies, and I think realistic studies with the right kinds of particles. Most of these lab studies are using microbeads, and you hardly ever find microbeads out there compared to fragments and fibers. So the worst areas that we've seen, like in Lake Erie, are about 32 microparticles per cubic meter, so 1,000 liters. And in that same body of water, we got orders of magnitude higher concentrations of phytoplankton of a similar size range. So the Daphnia that comes along eating those phytoplankton is going to have a hard time finding those 32 particles that are there. So the math just doesn't add up when it comes to exposure. I'm the editor-in-chief of Environmental Toxicology and Chemistry. I look at about 1,000 papers a year, and I look at probably 1,000 microplastic papers. And as we all know, peer-reviewed varies dramatically. And one of the reasons that we've had a lot of papers published that in my mind shouldn't have been without appropriate caveats is because the people reviewing them weren't eco-risk people. They didn't really get the realistic exposure piece of the puzzle. So yes, those studies were useful, but when we start extrapolating out to the environment, that's where we need to start questioning the findings, particularly on these that are quantifying it's so exciting to hear what we heard this morning about the new methods that are coming along, because 32 to 76% of the counts out there in papers are false positives. I mean, that's a horrible number. So we've got to get better numbers before we can really get a handle on what's going on. This is one of the great reports that's come out. It came out in December, and our own Bart Coleman's here was chairing this group, the Science Advice for Policy by European Academies, 25 academics in Europe that did a lot of thinking about all of the different issues with microplastics, and really did a summary of the state of the science. And I highly recommend that you download this and take a look at it. These are other critical reviews that are to the left. They're all basically finding the same thing. And it's the exposure issue, it's the methods, it's the quantification. Those are where the big unknowns are. So in closing, I think our major problem with plastics right now is macroplastics. We've seen the horrible things that it does to fish-eating birds and reptiles and mammals. Clothing fibers are probably our biggest source right now. If you think about the concentrations that are coming off of after washes, we could have one family contributing trillions, many trillions of microfibers per year just from their wash. This is just going to go up. It's going to go up. Today, the first day, I saw on Instagram somebody selling hoodies that are made of recycled plastic that don't shed fibers. So, it's a new market angle too. But this is a big deal. And if we're going to start trying to, and it'll be interesting to see what the panelists tomorrow have to say about dealing with this issue. And then this last bullet, this bolded relative risk ranking, that's really the only thing in this talk that's a Burton opinion. Most of everything's been from the literature. But if we look at what's really impairing the ecosystems, it's organic enrichments, it's nutrients, it's habitat and sediments, pesticides and PAHs and metals. And then we've got all of these other things that we tend to do a lot of research on, endocrine disruptors, pharmaceuticals, personal care products, and microplastics that are in kind of the other category. So like all the other speakers have said, we've got to have better methods, standardized methods, and I think we have to be looking at the small stuff. Thank you very much.
Great.
Out of time.
Thank you very much.